So today's lesson, we're going to talk about how to look at linear and nonlinear relationships. And we're going to look at, if we look at a table of values, can we plot points and determine if the relationship is linear or nonlinear? So a relationship is a description how two variables are related. A relationship can be described in many ways, including a table of values, a graph, and an equation. And we're going to be able to tie these things in so that they all represent the same thing. So a linear relationship makes a straight line on a graph. All right, so we're looking at making a straight line linear. If the relationship is not linear, we say it's nonlinear. And that's what we're going to look at today, is be able to say, looking at a relationship, is the relationship linear or not linear? So we can take a look at these pictures and say to ourselves, is this relationship linear or nonlinear? And we're going to be able to look at this, and some people can say, by looking at that, the hard part is, how do we justify that thinking? So we look at our shape here, we look at counting how many squares we have, and it's related to the figure numbers. So figure 1, there's 1, 2, 3, 4, 5. We look at figure 2, there's 1, 2, 3, 4, 5, 6, 7. And we look at 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. And you ask yourself, okay, is there a pattern? And just like with any math, you ask yourself, okay, can you continue that pattern? And hopefully you'll notice here that all these increase by 2 as these increase by 1. And you might have seen this from previous learning. And what we can do is we can take a guess on what those next terms are going to be. Hopefully you'd say, well, if I add 2 each time, the next one should be 11. And if I look at this, the next one should be 13, and so on, because the pattern is increasing as we go. We can also plot this as a graph, and we're going to label these as 0, 1, 2, 3, 4, 5, and I'm going to go up by ones here, 3, 4, 5, and it says here underneath, it says, when choosing scales for your graphs, make sure your numbers are a consistent pattern. So you count by 1s or 2s or 4s. And you know what, if I look at this, those numbers are getting big. So maybe, you know what, I'm going to count by 2s. 2, 4, 6, 8, 10, 12, and so on. And just like in the previous lesson, we can plot points. 1 is 5, 2 is 7, 3 is 9, 4 is 11. And we can look at this and say to ourselves, what's the pattern? Well, again, the pattern looks like a straight line. So what I can do with my pattern is draw my line. All right. We would say that this is linear because the graph is a straight line. Now, if we look at this, all right, did we figure out what 0 was? No. But we could probably continue the pattern backwards and say that is 3 because we subtracted by 2. Does that match our graph? Yep, it matches right there at 3. So the pattern is consistent through it. So this is linear because we have a straight line from our graph. But also, my pattern is constant because I'm adding 2 for each step. That's what I'm looking at. All right. And we could technically move on. We could also eventually make an equation out of this, and that's something that we're going to look at as we move forward. All right, so now we have just numbers now. All right, Kennedy rents a hall for our annual award ceremony. The following table of values is in the flyer for a hummingbird hall. Is this relationship between the total cost and the number of guests linear or nonlinear? Justify your answer. So what I want you to do is push pause, and I want you to take a guess, is this linear or nonlinear? And then unpause for the answers. So hopefully you looked at that and said to yourself, I see that these numbers are increasing by 100, and I see that the guests are increasing by a constant amount. So we can say here that this is going to be a linear relationship because the cost is increasing by $100 for every 5 people. And if you want to really think about it, is that it's going to cost $20 per person. All right, that is a constant rate. All right, so what does this look like in our graph? Just like we said on the bottom of the previous page, we can modify our scales. All right, I see these are increasing by 5, and you know what? Maybe I do let's do every 2 is 10, so 10, 20, 30, 40, 50. And one of these things, what we can do with these is, that's called a break in the graph. And what that means is all this information, and let's start at here at 300, all right? All the information from 0 to 300 has no meaning. So we can basically kind of start at 300 because nothing's really important after or below $300. All right, I'm going to go up every 2 lines is 400. All right, 600, 700, and be able to plot the points. All right, so I've got 0 is 300, 10 is 500, 20 is 700, and guess what? This is a linear row. All right, this has a constant slope, and we're going to talk about that moving forward. All right, different ways of looking at it. Okay. The next example. Is this relationship linear or nonlinear? Well, let's count the squares. Actually, you know what? I want you to fill in those 3. And I want you to push pause. All right? And I want you to predict what could go in 0 and what could go in the 4. All right? So go ahead, push pause, and see what you get. So hopefully you would have counted those squares. And you look at those patterns and say, well, is there something consistent? Well, if I look at this, I added 7, and here I added 9. Do you think that's linear? Hopefully he said it's not linear. Because these values, my rate of change, how much are these changing, are changing. And hopefully you'd say, there might be a pattern in that. You might say that these values are increasing by 2. So that could be adding 11. And then I could say, add by 13, or add by 15. And then I can go back and say to myself, well, 26 add 11 that is 37. And then I can go 37, add 13, I get 50. And that's 6, 50 plus 15 is 65. Likewise, you could ask yourself, I probably added 5 here because these are all changing by 2. So 5 plus 5 gets me my 10. So this is nonlinear because my rate of change is not constant. It's not the same. These numbers are not the same. And I can show that on my graph. All right, I'm going to go up by 1, 2, 3, 4, 5, 6. I don't know, maybe we go up by tens. 10, 20, 30, 40, 50, 60, 70. So hopefully when I do this, am I going to get a straight line or a curve? All right, so what I want you to do is plot these points on the graph, push pause, and then come back and see if your graph matches mine. So hopefully when you plotted this, and I know it's kind of hard to see here, this is not a straight line. And if I bring my ruler in here, you can really see the difference. My ruler is a straight line. This line, the slope of that line is changing, right? I can't draw a straight line there. All right, so there's 2 ways of looking at it. All right, I have a curved line, or my rate of change is different. That's what makes it nonlinear. All right. So let's look at this last question. Bakery is trying to determine the number of bakers needed to hire to meet the demand of the loaves of bread. They record observations in the table below. Is this relationship linear or nonlinear? All right. So again, I'm going to look at this. How much is this increasing by? 400. How much is this increasing by? 300. How much is this increasing by? 200. How much is this increasing by? 100. How much is this increasing by? 50. So my question to you is, linear or nonlinear? Hopefully you said nonlinear, because these numbers are not the same. Not a constant rate of change. All right, and then I can sketch my graph. All right, 1, 2, 3, 4, 5. All right, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's go up by hundreds. 200, 300, 400, 500, 6, 7, 8, 9, 1,000, 1,100. All right, and then I can plot my points. 0, 0, 1, 400, 2, 700, 3, 900, 4, 1,000. All right, and if I look at that, it's going to look like that. Curved line. Again, nonlinear. All right, so if I'm looking at what are the basic things that we need to be able to do is, if we go back to this, the idea here is we can look at a table of values and a graph to describe if a line, if a linear relationship is linear or nonlinear. The idea here, if it's linear, it's got to be a straight line. If it's not linear, it's going to be a curved line. All right, so go ahead. Try practice 29, give it a go, and see how it goes.